Hello and welcome to Tonight at 8 from the RSGB. QRP means transmitting at low power and is popular with lots of amateurs, many of whom enjoy the challenge of seeing how far they can make contact using just a few watts. This makes QRP ideal for portable operation, as the equipment can be small and require relatively little power to operate. It also makes it ideal for home construction. Tonight's guest is Hans Summers, G0UPL, who 8 years ago gave up his significant career writing investment banking software to work full-time with his QRP Labs business. He's now well known in amateur circles worldwide as a creator of affordable, innovative kits, and tonight he's here with us live from his home in Turkey to talk about his latest multi-band multimode transceiver, the QMX Plus. So welcome to Tonight at 8, Hans. Can you briefly tell us about what you'll be covering this evening?
Thank you, David. Yes, I'm going to give a quick description of what QMX Plus actually is. I will talk a little bit about how I got to QMX Plus, the things that preceded it, the heritage, if you like, and then the features of QMX Plus in some more detail and quite a few technical aspects, because I think some of the technical aspects are quite innovative and interesting. And at the end, I'll just briefly talk about what's planned for the future of QMX Plus, because the firmware is still evolving.
Lovely. Well, we're really looking forward to this. And if you're watching this on Monday, the 8th of July, then this is live. And you can ask questions or make comments on either YouTube chat or BATC messaging at any time during the presentation or straight afterwards. Please include your first name and call sign if you have one within every message. And note that you can make this video stream fill your screen on most devices, usually by double-clicking on the picture or pressing the full screen button. So now let's go back to Hans to find out more about the QMX Plus.
Thank you, David. I will jump straight in with a list of some of the main features of QMX Plus. So it's quite a small unit, just 106 millimeters by 55 millimeters front panel. And as you can see, quite a simple user interface with a couple of knobs and buttons and a simple 2 by 16 row display. But internally, it involves a very high-performance embedded software-defined radio to implement a complete 160 to 6-meter transceiver multi-mode with an included SWR bridge, SWR protection, and a bunch of other options too. So it's available in a kit form normally, or also in assembled form. So we have now 12 employees here in Turkey, most of whom are building assembled radios, and we managed to build about 200 to 250 assembled transceivers across the range every month. And so it's also quite a popular option for people. The QMX Plus also includes a 24-bit USB sound card and a virtual COM serial CAT port. So it's extremely easy to interface to digital mode software like WSJTX or logging software like N1MM. It has a TCXO reference PLL for extremely high accurate VFO and a CR2032 coin cell battery backed up real-time clock. So this is new for this transceiver, the QMX Plus. It also has an optional internal GPS and an optional development kit. So I'm going to talk about all of these things in a bit more detail now. But before that, I want to talk about, as I mentioned, the heritage, how we got to this point. And it all started back in 2017 when I had an email from the RSGB asking for a proposal for the kit buildathon for the YOTA summer camp, which was going to be held in August 2017. When I saw the budget was about £1,000 for 80 people, as I recall, 80 or 90 people, I just laughed and deleted it. What could you do for such a money if you divided £1,000 by 80 people? But my mind kept coming back to it, and over the following few hours, I kept thinking, well, what could you do, and what if you subsidized it and made 500 kits and sold the rest at a profit, and what if? And by the evening, I'd actually undeleted it and written a proposal back to the RSGB, which over the next couple of months was eventually accepted and went ahead to make the QCX transceiver. So this is a picture of the QCX. It was a single board, single mode CW, analog transceiver design, complete analog receiver chain and transmit chain, but with a digital PLL VFO and a microcontroller controlling everything. So the microcontroller provided things like a Kia, AB, VFO, RIT, frequency memories, message memories, and it also had very nice built-in test equipment. And the original idea behind that was I had sort of nightmare visions of the poor supervisors of this buildathon rushing around with their 80 young people trying to get the radios working. And they certainly weren't going to have 80 sets of signal generators and test equipment. So I wanted all that built in to make it easy to set up. It also had a very high performance, which I will come on to later. That evolved in 2020 into a larger version, which was QCX Plus that you can see there on the left. And then people said, well, that's a bit too big. We prefer the smaller form factor and a more portable sort of form factor with a display on the top. And so I decided to make a further evolution into the QCX Mini, which is what you see there on the right. And it was really my first foray into heavy density SMD circuit boards. Prior to that, most of the kits were almost completely through-hole, except for one or two components that were only available in SMD. So QCX Plus on the left and QCX Mini on the right, and that was what all happened in 2020. And you can see I solved the mechanical problems I'd had with the earlier QCX design, where the controls and connectors were all at different heights, and it was quite difficult to box up. And I never offered an enclosure for it, although a third-party provider in Germany did. So that solved the problem with QCX Plus and QCX Mini, and also got me into mechanical design of these extruded aluminium enclosures and working with factories on producing those. Then in 2021, I produced the real predecessor to QMX, which was the QDX digital modes. It stands for QRP Labs digital modes transceiver, which was a 6-band transceiver in a tiny package. So this is only, the front panel there is only 63 by 25 millimeters, and it's 86 millimeters deep. And it implements a complete software-defined radio using the STM32F4 series microcontroller. So this is an ARM Cortex M4 32-bit microcontroller, very powerful. It also includes the 24-bit USB sound card and virtual COM serial port. And it was also when I started experimenting with pin diodes for band switching. I'll talk more about that in a moment too. So that was QDX in 2021. And then in 2023, I produced the QMX, which is the radio that you see there on the right-hand side. And this was basically, if you took the mechanical design of QCX Mini, which you see there on the left, and the SDR and the digital features of QDX, and you put all of that together, you came up with QMX. So internally, it's a software-defined receiver based on the QDX, but it has the addition of the, so I'm pressing the wrong buttons here. It has the addition of the user interface and the controls, audio output, and envelope shaping for CW. So those two combined made up QMX, and that was in May 2023. It's been a very, very busy year since then. Almost 5,000 of these kits have been shipped now. So the latest, now back to the latest, the QMX Plus. This was announced in May 2024 at Dayton FDIM and Hamvention, and it's basically a larger QMX in the QCX Plus style enclosure. So you'll remember back a couple of slides, I showed how the QCX had evolved into the QCX Plus, and that was the enclosure for it. This is basically the same enclosure, but with some modifications to the front and the rear panel. So another point that I want to make at this point, the kits, these 5 transceiver kits, which are summarized there, which I've just been through, are very reasonably priced. The prices that are on the screen here are in pounds as converted yesterday, and they include the enclosures. So that's basic kit price plus the enclosure price. So you can see that they're very, very keenly priced kits for the performance involved. So this is how the kit looks like, David, and you mentioned you had a kit there that you've just received from me and that you were going to unpack and show people what that's like. I don't know if you've got that to show people while I talk about this.
Yeah, absolutely. I'll just quickly explain, if I may, in fact, that my club, Norfolk Amateur Radio Club, we had some interest in this at our recent little convention that we have here in Norfolk, and somebody said, can you just see if we could do a little mini bulk buy of kits for the club, and we got 7 of us interested in it. So we did that, and we made quite a saving on carriage. I can just say that for people. So if you do want to club together, just a few of you to do it, there's quite a significant saving on carriage, and we got them in about a week. So I have got one in front of me, and like many things, although I've only had it about a week, so there's a reasonable excuse, sometimes these things end up in drawers. I don't think I'll be the only amateur who says this, but I've got one in front of me exactly as we received it, just undid the bubble wrap. So if we go to that camera, actually I can just show you. So this is the sort of bubble wrap it comes in, well packed. I'm going to open that up. This is the top of the case, or one side of the case. There's some feet and screws there. The front and back panel, which are beautifully silk screened. There we go.
Actually, they're laser etched, David.
Oh, they're laser etched. Right. That's why they're perfect then.
It's supposed to be more durable and higher resolution than silk screening.
Yes. Well, they certainly feel it, and they're beautifully. Are they painted then, or anodized, or what's the finish?
There is anodized aluminium. So first they do the CNC cutout for the LCD front panel and the drilling, and then they do the anodizing, which makes everything black, including the insides of the holes, and then they do the laser etching as the last step. I
wondered how you did the inside of the holes, because I was going to comment on that. So they really are very nice panels, and I can hold the camera's a long way away, but I can just try and get that so you can have a better picture. There we are. So anyway, back to the electronics now. If I move that more over, does feel more like Blue Peter this than Tonight at 8, but there we go. This is exactly as it received, because my wife will agree with me. She's sitting next to me, and she'll say that this hasn't actually been opened yet, which is like many of our kits, isn't it? But this is what it looks like. And one thing, and I hope you don't mind me just picking one thing up, because some of the people watching may not be very much into construction or modern construction. You mentioned SMD, and we should just say that means surface mount device, doesn't it?
Yes, yeah.
And just for those who are not familiar.
And in all these kits, the surface mount devices, some of them are truly miniature, and you'll be able to see on the board there. And it would be very much to expect the majority of constructors to be able to solder those on by hand. So they're already pre-soldered by the factory. Yeah,
and that's important, isn't it? In fact, I literally haven't opened this before. I'm not wearing anti-static materials, but then we have got fairly good anti-static studio here. So I could just show that as well. So you can see there are surface mount devices on both sides of the board. There's the top side, I guess that is, and the bottom side. So they're all being done for you. So I would just say, as someone independent from you, Hans, that if the idea of making these as a kit puts you off because you've seen the pictures and you've seen the surface mount and you're worried about soldering it for the first time, don't be, because a lot of the building will be in all of these conventional, as we call it, or through-hole parts. And then just to really just quickly show, because I need to get back to you to do this, just a bag of what looks like connectors. This is really like a true unboxing video, because I hadn't got this far before. There's an LCD display, I guess it is, the 16x2 line, isn't it? Display, that's all assembled. Another circuit board here, which I didn't know about. Don't think there's a couple of small surface mount resistors on, or capacitors on that.
That's the front panel board, David, for the LCD module.
So yeah, so that's where you'd put the LCD, goes in, covers a lot of that. And then a tiny little board here. So do tell us what this is, Hans.
Well, that's where you solder on the two 3.5mm connectors which protrude from the front panel. So one of those is for the audio output, the earphones, and the other is for the CW paddle input, or the microphone and PTT input if you were doing SSB. And the easiest way for me to actually get those at exactly the correct location to poke through the front panel without having to extend that very expensive main 6-layer board was just to make this small insert board that the connectors sit on and is then soldered to the main board. Right, so the main board is 6 layers, and it's quite expensive to produce a 6-layer board, and therefore I definitely didn't want to sort of extend the whole board forward an inch just so that I could have those 2 connectors for the front panel connectors.
Indeed, and I guess now, and again, this really is the first time for me to looking at this board like this, but I guess these are going to be coils, inductors that you're going to.
That's right. Yeah.
And this is one of the things that you do have to wind yourself, isn't it? Because there is the last bag in the pack. And you can see there's some little hanks of enamel copper wire and some little ferrites. And
that's right.
So these look like capacitors in there as well.
Yeah.
But nothing,
So
would it be fair
yes,
to say nothing terribly small for somebody who enjoys construction but maybe has been put off by really micro miniature components? Would you say that was fair?
there's nothing terribly small. All the capacitors and the toroids are shown in the main photograph and the slide when we get back to it, and there's nothing too small. The toroids are larger than the toroids in the QMX that I showed previously, the really small one. So this is definitely easier to solder, and I think it also makes it easier that all the low pass filter components and the pin diodes and inductors are all symmetrically laid out, so they all point in the same direction and are symmetric on the board, which makes it much easier to build. The other nice thing is that all the surface mount components on the bottom side of the board are kept in the front half of the board when the board is installed in the enclosure, so that the rear half of the board is where you do all of those through-hole soldering. So unlike on the QMX kit, which is extremely compact, on the QMX Plus kit, you don't have to kind of dodge SMDs when you try and solder the enameled copper wire on the bottom side. The only thing that makes it difficult really is that being a 6-layer board, and I really pay extensive attention to the ground plane and how contiguous that is and stitched in regular places to get the EMI performance, to stop the digital noise getting into the analog sections. That really sucks the heat away. So you're well advised to use an 80-watt iron with a not too fine tip. I wouldn't go for a really, really fine pointed tip, because that will limit the amount of heat that you can get into the board. So particularly on the ground connections, all those 6 layers of copper ground planes do suck away the heat quite quickly. So that's the only thing to watch out for. Use an 80-watt or 60-watt iron, and do not be tempted to use a really, really fine pointed tip. Use something 1 or 2 millimeters tip, and that will be fine.
I thought just for scale on TV, because you can't always see how big things are. This is just a regular Parker sort of pen, and you can see the size of my pen compared to those pads for soldering, and they're not really that small, as you say. So I can see, although
none of the pads are closer than 0.1 millimeters together. That's the finest pitch that you have to solder.
Which is the standard pitch of an old-fashioned sort of integrated circuit, isn't it? Really?
Yeah, that's right. Yeah, or any sort of pin header, that type of pitch. All these capacitors are 0.1 inch spaced, and so it's really, you don't need a very, very fine iron, and a fine iron will just restrict the heat flow into the board, which will make it harder to solder on the ground connections.
Good. Well, we'll go back to your slides now, but if you want and look at any of these later, unlike Blue Peter, I hadn't thought about what I was going to do with these once I'd opened it, so they're going to be on my desk here. So if you want to refer to them at any time, Hans, do so, but we'll hand back to you for now.
All right, thank you. So yeah, that was fun. So this first slide here just shows the 32 capacitors that have to be installed, and there are 19 toroids and 2 binocular ferrites, which are the ones in the top right-hand corner. The toroids are all color-coded, and it's important to get them in the right places. But, toroids are something that are not really difficult to do as long as you can count reliably, which hopefully most of us can. There's not really anything to be afraid of. So this first slide is the toroids and the capacitors, which are in one of the bags. And the next slide here shows all the other components that have to be installed, including the button caps for the buttons and the knobs for the rotary encoders, the 47 microhenry inductors at the top left there, diodes, transistors, bits of hardware, so nuts and the spacers, and all of the connectors. So, you can see between those 2 slides, that's the sum total of all the parts that you have to install. So it's not a huge job to be scared of. It's quite feasible, and the instructions are extremely detailed. So provided you read them step by step and follow them carefully, it should all be successful. So as I said, it's a 6-layer PCB, and this is a picture of what it looks like when it's all assembled, and all those pre-assembled SMDs that you see on the left half there are already done. On the right half, as I mentioned, there are no SMDs on the bottom side, so it's quite easy to solder without damaging anything. And at the bottom left there, you see a picture of the rear panel and all the connectors on the back there. This is a picture of the front panel assembly. And you can see there in the middle this CR2032 battery, coin cell battery, 3-volt battery, and this is the backup for the real-time clock. So the QMX Plus is the first of the QRP Labs kits which actually has a real hardware real-time clock which runs from the battery even when the power is disconnected. The other transceivers also have a real-time clock, but it's done in software. So as soon as you power down, you lose the time, and it no longer keeps the time. The CR2032 is not shipped with the kit because we're not allowed to ship batteries, and there doesn't seem to be any way around that. But the 2032 is by far the most common type of battery that you can find. I mean, here I live on the coast in a very rural area, and all of our supermarkets have the 2032 battery, and it's also the cheapest of any of the coin cell batteries. It's much higher capacity than we need, and at least if the data sheets are to be believed, it would keep the real-time clock running for 20 years. So it's oversized for its purpose. This is a picture of the optional GPS module. So there's a whisper beacon feature in the kit, where the kit can behave as a standalone whisper beacon with no PC attached. Whisper is a weak signal propagation reporter network and used for propagation and studies. And the GPS is really useful if you want to do that. Now, this PCB is really, really tiny. So just to give, so that you can understand the scale, the GPS module there is 10 by 10 millimeters, and the spacing between those pin headers is 0.1 inches. So the whole thing is about, I think, 18 by 16 millimeters, and it bolts onto two pillars there right at the back next to the BNC connector. And it also includes a patch antenna, an active patch antenna with a low noise amplifier in it, and 2 meters of coax and an SMA connector. The SMA connector you see there on the back panel towards the left next to the BNC connector. So there's then this development kit where people could make their own modifications. So the predecessor, the QMX, is a very compact kit for portable operations, SOTA and so on. But the QMX Plus has a huge amount of space inside the enclosure where people could really sort of let their mind go free with anything they want to put in there, like a tuner, batteries. You could even put a Raspberry Pi in there and make a complete remote station. There's a German QRP forum where one guy has already been building a tuner to go inside here. So there's a lot of scope for experiment and for modifications. The board is installed on 4 11mm spaced plastic spacers, which you can see there with the nylon screws holding them in. And there are also pads in all the crucial locations which line up with pads on the main board for things like the I2C bus, the power rails, the low pass and band pass filter switching signals, the audio signals, and there are also 11 GPIO pins which are connected directly to spare processor pins and will be used for future expansion to control things, and you'll be able to write some scripts to control it. So I'll come on to that a bit later too. The documentation is very, very detailed, and the assembly manuals are really step-by-step manuals, and many people have compared them to Heathkit days for the manual quality. And the schematics are all online. The board traces are all online, as you can see here. The firmware is not open source, however, so that doesn't please everybody, but that's the path I've chosen to follow. Here is a block diagram of the whole QMX transceiver, and I'll talk in more detail about some of the more interesting parts of this, not every section of it, but some of the interesting parts. And you can see the STM32F446 processor on the bottom right-hand side there. And the architecture, if I go ahead to the next slide, which shows the receiver architecture, is really a classic baseband IQ software-defined radio. There are two types of software-defined radio. One of them is direct digital conversion. So things like the ICOM 7300 do this, where they digitize a huge chunk of 10, 20, 30 megahertz of RF spectrum. They digitize the entire thing, and then they do all of the processing in the microcontroller. The disadvantage to this is that you do require a very high performance computing to be able to do the DSP on that large chunk of spectrum, and you also use very expensive analog to digital converter chips. And in my personal view, it's not quite possible to build a DDC receiver at a reasonable price, which can meet the performance of a more sort of conventional IQ SDR, which mixes down to baseband. So here we use a 48,000 samples per second ADC chip. It mixes down to baseband I and Q signals, and then you do a Hilbert transform to obtain the relative 90-degree shift between the I and the Q channels. And from that, you can then sum or subtract to get upper or lower sideband. So that's how we cancel the unwanted sideband. And then once we've got all of that, it's all done numerically in the microcontroller digital signal processing. That's the block there, which I labeled DSP Magic. Then it's then converted back to analog using a 24-bit stereo 48,000 samples per second digital to analog converter, which you can see there on the right-hand side, and then audio amplifiers to the left and right channels of the earphone. So it's very simple to look at it conceptually like that. And of course, there's a lot of details internally. The ADC chip that I'm using has a 112 dB dynamic range, and that's a really high performance chip. Just by comparison, the chip in the Elecraft KX2 and KX3 has a specification of 103 decibels. So this exceeds that by 9 dB. And it really determines the performance of the whole transceiver in terms of dynamic range. The benefits of a software-defined receiver. So, I started off with QCX being an analog transceiver. I decided that would probably be the last analog transceiver I designed, because when it comes to SDR, you've got the potential to implement a really high performance and low cost, so a really high performance to price ratio. And you've also got the chance to roll out new features using just software updates. And so it really allows you a lot of flexibility with what you do. For example, in the original QCX, there was no AGC, and AGC was a later module that was added. Whereas in an SDR, there was also no AGC originally in the QMX firmware when it was launched a year ago. But it was, of course, all defined by software. So it was just a matter of writing the AGC within software. And not only that, it allows you to roll that out without any hardware modifications, just via a firmware update, but it also lets you really optimize and configure all the parameters that you want to use, and so that people can tweak it to their own preferences. QMX Plus does not, however, just implement a simple direct conversion receiver. It implements a superhet with a 12 kilohertz intermediate frequency. And the point of that is that often around direct conversion to zero IF, you get a lot of noise from mains, power line, hum, and things like that. And so you really get some significant improvement if you operate at a slightly higher intermediate frequency. So internally in the DSP, it actually implements a superhet with a 12 kilohertz IF. 12 kilohertz being a quarter of the sampling frequency just makes the mathematics much simpler. So internally, it uses 32-bit floating point processing. There are some embedded SDR transceivers which use 16-bit integer processing, and I think as soon as you do that, you've actually limited the performance to a maximum of 96 dB of dynamic range, because in DSP, the rule is that 1 bit is worth 6 dB. So 16 bits would produce a maximum performance of 96 dB of dynamic range. Whereas here I do everything using floating point internally, and so that gives a full precision, much higher dynamic range than the hardware is capable of. So the digital signal processing is certainly not the limiting factor in performance. It also provides 24-bit audio back to the PC via the USB sound card that I'll also mention in a moment. This is a picture of the microcontroller. So I've chosen here a really quite powerful microcontroller. I really like the STM32 series because there's a huge number of family members, and you can scale up or scale down according to how much I/O you want, which peripherals, how much memory you want. So here I'm using one which has 180 megahertz CPU, which is actually being run at 168 in QMX Plus. The reason for that is it's the frequency I need to be able to obtain the necessary clock frequencies internally for the I2S ADC peripherals and for the USB peripherals. It also has a 12-bit digital analog converter, which is used in part of the circuit, and a 12-bit ADC with lots of channels for monitoring things like voltages and forward and reverse power measurements from the SWR bridge. So it's a really powerful processor which provides hopefully plenty of space for expansion as the firmware develops and evolves. This is a schematic of part of the circuit for the quadrature sampling detector. This is also known as the Taylor detector and was developed by Dan Taylor N7VE around 25 years ago, 20 years ago, I think. And there was a radio called the NC2030, which was partially the inspiration for QCX, where he showed this in an actual transceiver design. And it had really, really high performance, very high dynamic range and intermodulation performance, the IP3 characteristic. I use it here in the double balanced format with this trifilar transformer ahead of it to split the signal into reverse phases. And you end up then with a very high common mode rejection of any noise from the power lines. And what you end up with on the far side is 4 phases, 0, 90, 180, and 270 degrees. And you take the difference of the 0, 180 to produce the I signal, and the difference of the 90 and 270 to produce the Q signal. It does require a quadrature local oscillator, which means 2 signals with a 90-degree phase offset. And I'm using the SI5351A signal generator and had already developed the way to produce this quadrature signal for the QCX transceiver. So here's one of the differential amplifiers for the I channel in this case. And the ADC chip that I'm using has a differential input. So it's got a very high common mode rejection due to that. And it's necessary to use the differential features if you want to get that whole 112 dB of dynamic range. So I went to quite a lot of effort to develop this differential amplifier and get the gain correct so that the everything is optimized for the dynamic range of the ADC. The op-amp being used here is the LT6231 op-amp. In my opinion, this is the absolute king of op-amps. Unfortunately, it's very expensive. Even when I buy 4,000 of them, they cost $4 each. So it's quite an expensive chip. But it has a very, very low input noise, 1.1 nanovolts per square root hertz, which is what determines the sensitivity of the receiver, because there's no amplification ahead of these op-amps, just the quadrature sampling detector to baseband. So the input noise of these op-amps is really what determines the receiver noise figure, and therefore the sensitivity. The LT6231 is quite unique among a lot of high-performance op-amps I tested, insofar as it not only has a very low input noise, but it also has an extremely high linearity, which gives it high dynamic range. Then after that comes the analog to digital conversion, and all of that happens in this Texas Instruments chip, the PCM1804 that I mentioned. And the results of that get sent to the microcontroller via this standard I2S bus. So the left and right channels are all digitized and sent to the microcontroller. And that's where the magic, or the DSP, digital signal processing, happens. For the audio output, I do everything in reverse. And here there's a very simple 8-pin chip, the CS4334, which is a 24-bit stereo DAC chip. It says it's on an I2C bus. That's actually a typo. It should be I2S bus. So the processor has 2 I2S buses. One is used for the ADC and one for the digital to analog conversion. And then I actually kept the left and right channels completely separately controlled all the way from the microcontroller, because there will be possibility in future to do things like have a higher volume in one ear than the other. So if people have hearing deficiencies in one ear, it will let us balance that up. And there are also possibilities for doing other things, like having binaural reception, or doing things like having a second receiver. So you'd receive one frequency in one ear and another frequency in another ear. And these are features which are really usually seen in much more expensive radios. But they're quite possible here. The hardware will allow it, and there's plenty of space in the firmware. So as the firmware evolves, I hope to implement some of those things. There's a USB connection to the PC, and virtually the QMX Plus implements a 24-bit sound card, as well as a virtual COM serial port for cat control. And all of that just goes over one cable. So really, you can imagine that there's a USB hub inside the QMX Plus with a serial port and a sound card connected. And there are actually enough resources to implement a second serial port as well. So that's also on my list of things to do. In the bootloader mode, the QMX Plus appears as a USB flash drive. And so I've got something more on that in a subsequent slide. I'll explain it. But firstly, about the USB audio, the real beauty of this USB audio transfer from the PC is that normally what will happen is that your software, such as WSJTX, will generate tones for digital modes such as FT8, and your PC sound card will convert those to analog, and then you will plug in a 3.5mm stereo jack cable and plug that into your SSB transceiver, which will then convert that back from analog back into digital, go through all its DSP, and then convert that back into analog to actually transmit it onto RF. And all this conversion back and forth produces loss, it produces distortion. You've got the possibility of noise and audio hum coming in over the cables. Whereas what we get with the USB audio is absolutely exactly the same numbers that WSJTX generates. We just get streamed straight into QMX Plus with zero noise, no distortion, no losses, no possibility of any audio overload. So it's a really beautiful system to have that USB sound card built in. Then the firmware update, as I mentioned, QMX Plus appears as a USB flash drive, and you just download the new file and unzip it from the QRP Labs website, and then drag the new file into this flash drive. So it's not a real flash drive, it's just QMX Plus pretending to be a flash drive. And really huge benefits to this, there's no hardware programmer necessary to be able to update the firmware. You don't need any software that you install on the PC. You don't need to worry about whether you've got Linux, Mac, Windows, or anything else. Anything that supports the USB flash drive, a memory card, will be able to do this firmware update. And it's as simple as dragging a file across. It also implements 256-bit AES encryption, so there's not going to be any possibility of any clones arising ever. The virtual COM serial is used by the PC to give commands to the radio to tell it what frequency to operate on. Sorry, I've accidentally gone some ahead here. So it tells the radio what frequency to operate on, and in the case of WSJTX, switches between transmit and receive, which is a more reliable way of enabling transmit than using voice-operated transmission. And all these digital mode software packages, they all use CAT to talk to the radio. And it applies to any radio, whether it's QMX Plus or an ICOM, Kenwood, whatever. They all use these CAT protocols to communicate between the PC software and the radio. The QMX Plus protocol is similar to the Kenwood TS480 with some extensions. And in fact, in the latest Hamlib libraries that you can download, there's QRP Labs has its own entry in the list. But it's also similar to TS480. You can also log in with a terminal emulator such as PuTTY to do configuration and alignment tools. So I've got some screenshots of that in a moment. Now, for one of the innovations that I implemented actually in QDX, but which is also carried over into QMX and QMX Plus, is a very, very clean transmission of FSK digital modes such as FT8. And the way this works is that the PC will tell the radio what the USB dial frequency is via CAT commands. And then QMX Plus will measure that audio tone frequency coming from the host PC and add that to the USB dial frequency, and then tell the RF synthesizer to produce that directly and transmit it via the power amplifier. And the advantage of this is that it's an extremely clean single carrier signal. There's zero unwanted sideband, zero residual carrier, zero intermodulation whatsoever. Now, if you've got an SSB transceiver, you always have some kind of residual imperfections. But in this case, we have just the absolutely perfect clean carrier because you're decoding what that audio tone is and then regenerating it at RF directly. The way this is achieved, this audio frequency measurement, you can't just count the number of cycles that you see in a second, which is the way that we would normally do frequency counting, because things like FT8, that frequency changes multiple times in a second. And you couldn't reduce the period that you measure for, because then you're also reducing the accuracy. So if you chose a 0.1 second measurement interval, for example, you would then only have a 10 hertz frequency measurement resolution. So normal frequency measurement doesn't work. So what we do here is a cycle period measurement, where the software looks for a zero crossing. So it looks for a sample which is above zero, and then a following sample below zero. It does a straight line interpolation between them to determine exactly the proportion of one interval where the actual zero crossing occurs. So it can count the number of whole intervals, each interval measuring 1/48,000th of a second. It can count the number of whole intervals between zero crossings, and then it can also add this extra bit at the beginning and the end, which is calculated by a straight line linear interpolation between these two samples above and below the zero line. So it sounds like it might be a very inaccurate way of doing things, but it's actually incredibly accurate. And it gets less accurate as you go higher in frequency, because as you go higher in frequency, there are less samples in each cycle. So I'm illustrating that in the diagram there at the top right. And then the straight line linear interpolation approximation, where x is equal to sine x, starts to break down. That approximation holds when x is small. And so if you've got samples which are getting to be further away from the zero line because there are fewer samples per cycle, then that interpolation starts to break down and get less accurate. But at high, so it's still, however, very, very accurate. And just to give an example, at 1,500 hertz audio, which is kind of in the middle of the audio range, the accuracy for measuring a single cycle is 0.005 hertz, so 5 millihertz, extremely accurate. So there's actually a tool, this is showing one of the tools in the, when you log in with a terminal emulator, that scrolls up and shows you the frequencies of the tones being received. And you can see that 0.05 hertz accuracy very clearly there. And you can also do some averaging, which further improves it. So what I actually do in QMX Plus by default is average 100 cycles. So the accuracy really goes even further. But given that a FT8 tone spacing is quite a few hertz, and even a whisper tone spacing is 1.46 hertz, these measurement precision is more than sufficiently accurate for the requirements. It also does a sufficiently rapid measurement. Now, by default, it does 100 measurements per second, but it can be changed, such that when WSJTX slides from one tone to the next, the QMX Plus follows it quite accurately. And that's also observable with these tools. There are other terminal tools, so when you've logged in with a PuTTY emulator, like the QCX originally, the QMX Plus includes its own built-in test and alignment tools, and so it has a signal generator that it can inject into the front end, and that lets you sweep the bandpass filter, which is the example shown here for the 20-meter band for the QMX Plus. But there are also sweeps for the low-pass filter. You can sweep the SWR of your antenna using the SWR bridge that's built in, and that you can access the entire configuration menu from the PuTTY terminal and diagnostic screens to help you evaluate if there are anything not quite right with the radio. So a lot of powerful tools built in as well. Now, we've talked about the receiver. Now, moving on to the transmitter, the power amplifier is actually a Class D, push-pull power amplifier in Class D. So the transistors are switching in saturation, fully on and then fully off, and then push-pull, and the two halves are then summed together with an output transformer, much like most linear amplifiers, but here we're not operating in linear, we're operating in Class D. And the advantage of this is that you have very low even harmonics. Even without any kind of filtering, the even harmonics cancel out. And I typically measured around -70 dBc of even harmonics, a second harmonic. It's also very efficient because the transistors are either fully on or fully off. It's not as high efficiency as Class E, but it does have the advantage that it's broadband. So in a multi-band transceiver, the Class E amplifier becomes quite difficult, whereas Class D is quite easy. It works very well with low-cost BS170 MOSFET transistors and driven by a simple logic gate 704ACT08. And we actually use two BS170s on each side, so 4 in total. It does need this anti-phase drive to push the two halves opposite to each other. And it's possible to either wind the output transformer with a 3:3 ratio, and that produces 5 watts from a 9-volt supply, or you can run it for a 3:2 ratio output of turns, which is suitable for a 12-volt supply. This is a diagram of the power amplifier section, so you can see those two sets of BS170 transistors there in the middle, each of them driven by a 74ACT08 gate. And then on the left-hand side, a couple of exclusive OR gates, which are inverting the signal, the clock 2 signal from the SI5351A to generate the anti-phase drive. On the right-hand side, you can see the transformer that just adds those two pieces all back together again. The big advantage, of course, is that having this very low second harmonic, you don't have to worry so much about having very many elements in your low-pass filter. So here I'm using a 6-element low-pass filter, which is 5 convention elements, plus a third harmonic trap, which you can see in this example is I don't know if you can read on there, but it's a 56 picofarad in element 4 from the right. I use LC simulation to optimize these filters, and it's a very nice, easy to use piece of software, freeware. So having a low second harmonic lets us arrange simpler low-pass filters, and it also lets multiple bands share one filter. So in QMX Plus, there are 6 low-pass filters, but it has band coverage from 160 meters to 6 meters, which is 12 bands. So you can see that there's some sharing going on, and that's all possible because of this even harmonic being cancelled out by the push-pull amplifier. There's also an envelope shaper, and this is very important for 2 reasons. Firstly, for CW, so you need a very nice shape on the leading and trailing edges of the CW envelope. Otherwise, you generate key clicks several hundred hertz away or even further away, which will upset other band users. So I developed this amplifier, which has a gain of about 6, has a very linear output voltage versus its input voltage. And it really behaves somewhat like a sort of high power op-amp in its behavior. And the aim is that this digital to analog converter voltage from the microcontroller can then control the power amplifier voltage very, very precisely. And the other big reason for having this is because when SSB is going to be implemented in the firmware, and I'll talk about this in a moment, the SSB requires precise control of the amplitude shaping. And this circuit is extremely quick. It has a bandwidth of at least 100 kilohertz, so it can really respond quickly to changes on the digital to analog converter voltage, plenty fast enough for SSB modulation that we're going to need. Here's a chart showing the output voltage, peak-to-peak voltage. So 45 volts on the left-hand side there corresponds to 5 watts power output. And it shows how the supply voltage to the power amplifier, being very linear with control voltage from the DAC, controls this output envelope amplitude. Very nice linear straight line. So as I mentioned, we have 6 low-pass filters, and conceptually there's a SPST switch ahead and after each one, and I only show 3 in the block diagram here, and it continues below the bottom of the page. So you can see how the bands are shared between these low-pass filters. I included 11 meters. It's not an amateur band, but it's a CP band, which is popular in Europe and some other countries. So there's a switch before and after each low-pass filter so that one of the filters is selected at any one time. Now, for switching, I used pin diodes, and as I said, I sort of started on this back in the QDX in 2021, and I really love making pin diode switches because relays are quite expensive to buy. They're heavy, mechanical, noisy, slow. They could get unreliable after a time. Whereas if you use a diode, it's a solid state component with a very good durability. And surprisingly, PIN diodes are very expensive, but the 1N4007 actually makes an excellent HF PIN diode, and you'd be hard pushed to find a better real PIN diode, which would cost 100 times more than a 1N4007. So it's a very pleasant surprise, and it's because the 1N4007 has a very high 1000 volt reverse breakdown voltage, and it means that the way they construct it has a similar construction to a PIN diode. So the rules for PIN diode switches are that if you want the PIN diode to conduct, to be on, you have to pass a forward bias current through it, and one of the details here is that the more power you want to put through, the more milliamps of bias current you need to avoid any distortion, meaning any second harmonics being generated. And for when you want the PIN diode to block, so it should be off, then you apply a reverse bias voltage, which is larger than the signal being blocked. So these are the two rules for PIN diodes, and as long as you remember those, you can make very complex switch architectures with them. This is actually a diagram from the QDX, but it's exactly the same in the QMX Plus, and it shows the low-pass filter there in the left half of the page, and the various voltages. So you could follow this through and work out how those two diodes, D3 and D6, to the left and right of the low-pass filter, are not conducting. They've got a high reverse voltage across them. Now, the way the reverse voltage is generated is also quite interesting. So on the right-hand side of the page, you can see if I have a 45 volt peak-to-peak signal, which is a 5-watt signal, I certainly don't have 45 volts of DC available in my circuit, which is the radio is powered from 12 volts. So the question is how to get those 45 volts of DC to reverse bias the diodes into the off state. And the answer came in the form of this circuit with these three diodes on the right-hand side of the page there, which is a doubler and rectifier. So it takes that 45 volts RF and doubles it and rectifies it and ends up with a voltage which is somewhat higher than the 45 volts. So I get a DC voltage which is high enough to block that 45 volts peak to peak. So it's quite a nice way of generating that high voltage. The current requirement is very low, so it doesn't steal very much energy from the RF signal. Here's a diagram showing in the on state, and typically push around 30 milliamps through each of these diodes, and you can follow all of that through on the diagram there. So these two diodes before and after the low pass filter are following those rules about forward bias current in the on state and voltage reverse in the off state. So a little bit about SSB on the QMX Plus, and the SSB has not yet been implemented. It's the hardware was prepared for the SSB, and even with the QMX 1 year ago, and it was certainly my intention to get to it before now, but so many other things came up in the interim that I didn't actually get to it. But the SSB is now the #1 priority on everybody's list. It's the next big thing that has to be done in the firmware. So now that Dayton and the Friedrichshafen German trip, Friedrichshafen and Radio Hamfest, are both behind me, I hopefully will get some time to work on these now as the next #1 priority. So QMX Plus already has a microphone built in, and I'm not sure if you can see it, but on the right-hand side of the front panel, right between those two knobs, you can see a tiny green dot, and that's a hole in the front panel behind which there is a electret microphone. And the green is just the backlight of the LCD backlight shining through that hole. So you can also plug in a microphone and a PTT switch into the paddle port, which is the 3.35 millimeter jack, second from the left-hand bottom corner of the front panel. And the idea about producing SSB, even in a transceiver, which has a non-linear amplifier, uses this thing called EER, envelope illumination and restoration. And perhaps the best known example of this is the micro STX and true STX transceivers, which were designed by PE1 NNZ and DL2 MAM. And the basic idea behind this is that you have your SSB signal and you kind of do the reverse of what we do when we demodulate INQ in order to get INQ. And then we convert that into an amplitude component and a phase component. So the amplitude component is found by squaring and summing and square rooting the INQ, and then the phase component by dividing I by Q and taking the arctangent, so that we then get a phase component in degrees and an amplitude component. then the amplitude component can be modulated onto the power amplifier using my amplifier with the gain of 6, which I showed in a few slides ago. And the microcontroller can provide a 12-bit digital to analog signal and very precisely control that power output amplitude. The phase modulation can be applied by a series of very quick frequency updates to the SI53518 frequency synthesizer. And so this was what they did with the micro SDX, and I will aim to do the same thing with QMX Plus. Now, in the micro SDX, P1NNZ amazingly managed to achieve this with a very humble 8-bit 20 megahertz AVR processor with limited memory, limited capabilities, effectively only using an 8-bit pulse width modulation and achieving about 20 dB of a non-linear control range by applying this smooth pulse width modulation to the gates of the BS170 transistors. And so you get this kind of typical S shape of the control amplitude of the BS170s. In the QMX Plus, we have a very powerful, as I mentioned, 32-bit ARM Cortex-M4 with floating point unit and DSP instructions built in, huge amount of flash memory and RAM, and a 12-bit high bandwidth digital to analog converter. And the amplifier that controls the power amplifier has 37 dB of linear control range with a very, very straight line. So hopefully, and all of the signs indicate that the hardware in QMX Plus is extremely capable and will therefore be able to produce SSB to quite a reasonable quality. Of course, the proof of the pudding will be in the eating, but hopefully the eating will be soon and the wait will be over soon. So moving on, QMX Plus also has an SWR bridge built in. There's not much to talk about here. This is a very standard arrangement. Here I use a single binocular core to wind the two transformers. An interesting property of these binocular cores is that if you wind a transformer on the two halves, as shown in this picture, electrically they can't actually see each other. It's like having two separate ferrite toroids and winding the transformers on them, but it takes up a lot less space on the board. So this was done for QMX, but it's just carried on over into QMX Plus, even though there's enough space in QMX Plus. And the output of this is a forward voltage and a reverse voltage, which are then fed into two ADC inputs of the microcontroller, and it reads those ADC inputs 1,000 times a second. And so it also has a SWR protection feature, which is defaulted to an SWR of 3, but is completely configurable. So if the SWR breaches 3, it will immediately shut down the transmitter and protect the finals. It'll actually do that while it's building up the envelope of the transmission, and therefore there will be no opportunity to do any damage to the final transistors. Now, I think this is the final anyway, the final detailed topic I wanted to mention before I finish is the switching power supplies, because this is one of really the most interesting and my favorite piece of the QMX Plus. And why we need switching power supplies is because particularly on the QMX, which was designed for portable operation, everybody looks at the receive current and judges transceivers based on the receive current. Because if you're in a portable scenario, your radio is going to be running from a battery, and you spend most of your time in receive and not transmitting, and therefore the receive current is a key parameter that determines how long your batteries are going to last. And even though QMX Plus is more of a sort of desktop design, it's still very small, and there will be plenty of people who will be using QMX Plus in a portable or battery-powered scenario. And so low receive current is quite important. And it turns out that when you have an SDR implemented on a powerful microcontroller, which is running at 168 megahertz, these things require quite a lot of power. And so the current consumption of QMX Plus is around 220 milliamps when using a linear power supply, which is significantly more than the 72 milliamps, for example, of QCX Mini or 112 milliamps of QCX Plus, these analog transceivers. And so the solution to this is to use switching power supplies, which convert to 3.3 volt supply and 5 volt supply for the audio sections with very high efficiency. There's also a pin diode forward bias, which is developed, and this was from the QDX transceiver. efficiently develops the forward bias current for the diodes during transmit. But the challenge of switch mode power supplies is the noise that they can generate. So the basic idea for, wait a minute. Firstly, this slide is in the wrong order here. Why SMPSs are noisy is because they switch the power on and off with a very, very fast switch. And it's important, in fact, that the switch is fast, because if it spends time between being completely on and completely off, that reduces the efficiency of the conversion. And the whole reason why we're doing this is because we want an efficient conversion. So unlike a linear regulator, which is like a controlled variable resistor and dissipates all of its heat as all of its voltage as heat, what a buck converter is supposed to do is switch on and off very sharply and hopefully minimize any wasted heat. But this does generate harmonics to the switching from DC to daylight, as they say, and it's very, very difficult to filter that out completely from your supply rails. Now, inexpensive SMPS chips have free-running RC oscillators, and these drift all over the place, and being such a low-Q oscillator resonance circuit, they also have high phase noise. So what you often see around many pieces of consumer equipment is these bands of noise spaced by 50 or 100 kilohertz or something like that. These bands of noise, several kilohertz wide, which drift up and down depending on how the load of the machine is or whatever. I've certainly seen this in my PC power supply, and it was very hard to get rid of. Now, in the QDX, which only has one buck converter used for these pin diode forward bias current switches, the noise didn't really matter because it was on transmit. They were only used on transmit anyway. But in QMX Plus, the switch mode supplies are used all of the time, so noise is very important. Now, the way I got around this is, firstly, in QMX Plus, everything is derived from this single 25 megahertz TCXO. It's a very, very low phase noise, high precision oscillator, which does not drift around. The microcontroller generates pulse width modulation for the switching circuit, and the microcontroller knows the operating frequency which the radio is on, and so the microcontroller can choose a pulse width modulation frequency which avoids QRM on the operating frequency. Now, in the current firmware, this is not yet enabled, but it will be soon, and even at the moment, there are very few instances of interference to the operating frequency because of the fact that the high stability and low phase noise oscillator is used. So going back to the slide which was out of order, the basic idea came from the QDX, as I mentioned, and the power supply was implemented using discrete components. Micro operates at about 100 kilohertz and has to read that voltage and then adjust the pulse width to keep it regulated at 1.5 volts in the case of the pin bias, but 3.3 and 5 in the case of the circuits for the QMX Plus. So this is a very good demonstration, and I really love this one, of what a huge difference it makes. So in this case, I had intentionally set up my PWM frequency such that a harmonic of it came up on 14072, or roughly 14072 kilohertz, so on the 20 meter band. And therefore, if you look here, you can see this very strong signal around 1439 hertz audio offset. And that's so the USB dial frequency here is 14071. That offset is the actual interference is on 14072.4, and you can see that the whole band, so this is in the top half of the picture, is covered in noise, and it would certainly be very difficult to decode any stations there unless they were very, very strong indeed. Now, if you just tune up 3 kilohertz to the FT8 band, that's in the lower half of the picture, you can see that the harmonic of the switching noise, even though it's only a couple of kilohertz below, is not really causing any problem here to reception on the FT8 frequency, just a few kilohertz higher up. So it's quite a nice demonstration of the fact that the noise is firstly very damaging, and secondly is quite narrow and localized. Now look what happens on the next slide when I change the SMPS PWM frequency and I look again at 14071. It's completely clear and noise free. And so it really illustrates the power of being able to control that pulse width modulation frequency to move the harmonics away from the operating frequency. You do have a chicken and egg problem, and which is that the microcontroller, being the control loop in software for the power supplies, is the microcontroller has to be started up first before it can provide the 3.3 volt supply. I was going to call this incest, but I know the RSGB likes to keep things clean, so I went with chicken and egg problem instead. And so the problem here is solved by using a linear regulator, the 78M33, which provides 3.3 volts linear supply and it enables the microcontroller to boot up and start preparing the pulse width modulation, get everything sorted out, and then can switch over to using the switch mode pulse supply using this signal lin reg n, which you see at the bottom left there. And here's a scope screenshot which shows how that happens. So it shows the power on, which is I've indicated there as T equals 0, and then the 3.3 volt supply is the blue one, and that hands over from the linear regulator to the buck converter at about 250 milliseconds after power up. The yellow trace is the 5 volt rail, and that also ramps up and is switched over, and then the audio systems are booted up as well. So all of this happens within the first fraction of a second after power up, and solves the chicken and egg problem. The 5 volt board also includes this soft power switch and reverse polarity protection. So if you did happen to accidentally supply voltage in reverse, then it would withstand that. And the soft power switch is basically that the QMX Plus does not have a toggle switch or anything like that to power it up and down. It has this soft power switch on the volume control encoder button. So you just give it a long press and it powers up, and another long press powers it down again. And I also like this because it allows you to save the current state of the radio, so what band it's on and what frequency it's tuned to, what volume it's at, and so on. It allows you to save all of that to non-volatile memory, the EEPROM chip. And so when you next power up the radio, it will come back in exactly the same state, exactly the same frequency you left it at. So this is just a slide showing the duty cycle, the pulse width modulation duty cycle measured for various supply voltages on the horizontal axis. The current consumption in practice is extremely successful. So it reduced that 220 milliamp draw on the linear regulators. It reduced that down to 80 milliamp with the LCD backlight off and about 86 milliamps with the backlight on. The backlight on or off is something that can be controlled in a configuration menu setting. And just for comparison, the Ellicott KX3 website page proudly says the receive current is as low as 150 milliamps. And I mention this because the KX3 also does a very similar embedded SDR with this baseband conversion and DSP, and so is achieving a similar type of receiver architecture. So really, I was very pleased with this 80, 86, 90 milliamp sort of supply current range on receive. It's a really good result and sort of validates the whole effort that was put into those switching supplies. Very briefly about the future, as I mentioned, the processor has huge resources, and currently the program is only using about 30% of the flash memory. There's also a CPU monitor built in, which shows all the processes in the system and what CPU percentage each process is using and how many times it's been called in the last 1 second. And there's also a scrolling indicator there on the bottom right of the screen of the last 30 seconds of activity. Mostly this was for my benefit, so I could try to optimize parts of the system that might be using too much CPU and understand when the processor starts getting full. But you can certainly see that it is currently using about a third of the flash memory for the program space and a third of the CPU time. So there's plenty of room for more features to be added to the firmware in the future. So my plans are, of course, SSB, which I already mentioned, and it's the big one everybody is waiting for. Customizable CW filter center and bandwidth is another one. So this chart that you see here shows the band pass of the QCX in blue and the QMX being its digital filtering in red. So the QMX is currently limited to a 700 hertz center frequency, 300 hertz bandwidth CW filter, but there are, of course, people who would like to have a narrower filter and other people who would like to have a wider filter. And the best way to make everybody happy is to make it customizable so that people can have whatever filters they want. So that's another big thing. As I mentioned, having the left and right outputs of the earphones separate allows me to have things like binaural reception, a second receiver, left-right balance if people don't have equivalent hearing in both ears. So all of those things will be possible on the audio. I'm also planning to implement a basic programming language scripting tool, which lets people customize the user interface and respond to events, and also control those 11 GPIO pins, which I mentioned earlier, which will really make expansion possibilities almost endless. So here, almost the last slide, just some details about where to find QRP Labs. So the website qrplabs.com and the shop, which is also linked on the website. We have a very active groups.io forum, which I would really recommend anybody building the kits to join, because there's a lot of discussion about enhancements, requests, and features, and behavior, and performance, and stories of what people are using them for. But most of all, if people have problems during the construction, there's a lot of help available there. And there's also the YouTube channel, which I don't make nearly enough YouTube videos for, but I probably should. So finally, here's just a summary of the QMX Plus pricing. As I mentioned earlier, I worked very hard to keep the prices very low. These prices here in pounds were converted using today's exchange rate. And so the basic kit, as you can see there, costs under £100, and then just under £20 extra if you include the enclosure. As I mentioned, we do have people here who are assembling 200, 250 radios per month. Across the 5 transceivers in the range, and there's an additional fee for that, and the GPS option and dev kit option listed there as well. So back to you, David. Thanks very much for the invitation and for tolerating me overrunning my time. I see I talk too much always, common problem. But if we have any questions, I'm sure we have time to consider those, and thanks very much.
Thank you, Hans. I'm going to let you have a quick break as well, because you have been giving us such a detailed rundown. Believe me, you haven't overrun at all. I know that everybody's been watching, as I've been watching the comments coming in, are enjoying it and have enjoyed everything you've shared. You've been so open about all of it as well, which is great. So thank you very much for that. If you have any questions or comments you'd like to ask Hans and haven't already done so, though, this is the time to do it, either on YouTube chat or BATC messaging. And please don't forget to include your first name and your call sign as well, if you have one. So I've got a couple of questions, but I'm going to leave those for the moment and go straight to our first question, which came in a little while ago. Is from Rasmus SA5RJS. Would it be possible to use the QMX Plus as a GPS disciplined 10 megs frequency reference? Maybe when you answer that, Hans, you can explain as well to some of us who don't know what that exactly means, what that means.
Yeah, so a GPS discipline frequency reference means you connect a GPS to some gadget and you get a very precise output frequency. The typical 1 pulse per second output from a GPS has around about 11-20 nanoseconds RMS variance on it. You can also, of course, as you have a very high precision TCXO, which is being disciplined, you can average those. So I have not currently implemented GPS discipline in QMX Plus. It would be something that would be technically possible in the firmware. I'm not sure how much demand there would be for that. I do have other kits which do that already, such as the VFO kit that I have and the ProgRock 2 kit. Both of those are can be connected with a GPS, and a GPS can be used to discipline to 10 megahertz. The precision at 10 megahertz is well below 1 millihertz on the ProgRock 2, so it's a quite precise option to use. So I would suggest that one of those kits would probably be cheaper and simpler and lower current requirements for such a purpose. But yes, technically it would be possible to do it in a QMX Plus if I was to write the firmware for that.
So Hans, I mean, if for these sort of, and you must get suggestions and requests all the time. If someone has a suggestion like this, where's the best place to put that? On one of the forums?
Yeah, I would say on the groups.io forum, which I posted just now, would be the best place to discuss it. Yeah, there is a continual stream of suggestions, and one of my tasks, I suppose, or one of my duties is to try to identify which of these suggestions would be attractive to a wide number of people and therefore make the time spent on it worthwhile. Whereas some suggestions would only be something specific to one person or a small number of people. And so it's sometimes quite difficult to identify those things. But one of the reasons I want to include the basic scripting tool, which into the QMX Plus, which will provide huge flexibility, is it will allow people to do their own modifications and their own coding and achieve some of these one-off wishes without me having to spend huge amounts of time on it myself. So that's one really big reason for doing this basic scripting tool.
Yeah, because earlier you mentioned that this is clearly your design in terms of hardware and everything is open design, and the very fact you're here tonight and talking so openly about the technology that you've developed for it as you've open, but not the firmware. So is this scripting tool then something that you hope will relieve the frustration of some who would just like these little modifications and things done and who are able to write code themselves?
Absolutely it is. And in the ideal world, you'd be able to make a code open source, and then everybody could just customize it to their own wishes. The two problems with that are that once something is open source, you end up with a sort of so much branching that it becomes hard to control it and it requires an awful lot of management time to try and keep it under control. And the second huge issue with that, of course, is that you can very quickly have your transceiver cloned. Often we think of the Far East as the people that are doing this, but I don't think it's limited to that. But there have been quite a few transceivers that I've seen in the last few years. The MCHF transceiver is one example of that. Even the True SDX is another example where clones were done in China and practically, ruined the business of the people who originally developed it. And so, for me, this is a business, and I do have to make a living to feed the family. So
of course. Yeah,
it's a concern. So having the firmware closed source, but trying to provide a scripting tool that enables people to do a huge number of things with it is kind of my attempt to get round that restriction and to at least let people play if they want to. Is not as good as it being open source, but it's at least something.
Absolutely, yeah. That seems a reasonable compromise. I think most of us, although some of us like to dabble and tinker, but we can understand as well you put an awful lot of work into this. And it is a business, even though the prices, to me anyway, as someone who used to design equipment for a living, are very reasonable. I don't think you're making huge amounts of money on these things. So trying to get that balance is right. And I think that most of us understand and respect the fact that you've got to protect your proprietary work, and a lot of it, I guess, is in the software, as you say, and then the firmware.
It is, yeah. I mean, 90%, 95% is in the software. The hardware is very difficult to protect anyway, because anybody with a DVM can trace out traces and connections if they try hard enough. So, it's in the software.
Understood. Okay. Next question. Now this is from Mark M5BOP. He does actually start with just a comment saying just to say that he has built and regularly used your QDX and is delighted with it. But he's got a question for you, more to do with, I guess, the operating of your shop than the technical size of the QMX. It says, Hans would like to order a couple of LPF filter kits for use in my own designs. Is there a lower cost letter rate postage you can use for such? Because FedEx and TNT shipping to the UK is far too costly for small items.
Yes, it's a good question. We used to use standard post office shipping, and we used to only use standard post office shipping. And then came the COVID-19 pandemic, and we were very lucky to accidentally have signed up with TNT shipping right before the pandemic started. And at that point, the standard post office shipping suddenly started taking 3 or 4 months. And there weren't many people who wanted to tolerate that. So we were very lucky that we suddenly got the TNT and FedEx options. And then we added DHL Express a year or two ago as well to the available options. And what we found since that time was, I don't want to get too much into politics here, but President Trump withdrew America from the International Postal Union on postage prices, last mile postage prices, in an attempt to avoid subsidized Far East shipping prices. And what that did was suddenly overnight triple the cost of US postage. And we found similar things then started happening in other countries too. And so the postal rates, even for small things, are no longer as attractive as they used to be prior to COVID. And we also found that the standard post office shipping has become extremely unreliable in comparison to TNT and FedEx. And I don't think it's because of Turkey. I mean, I never get my Radcom anymore either. And then suddenly, after several months, I get 3 or 4 of them turn up at once. And so post has become really difficult to do. So that's why we only do TNT and DHL Express. And really, to the UK, I think TNT is something like $10 or $11 or something like that. So it's really not bad.
Okay, just as a thought for you, I mean, you're obviously very successful and you're selling quite numbers now, and there must be some countries where you sell really quite significant numbers. Excuse me. So have you considered having maybe a distributor who could work on quite a relatively low margin, because all they're going to do is you consolidate big shipments of stock to them and then they ship it from the local country?
Yeah, I've have considered that. It's, I think, hard to do if you're a small business with low margins. I think if you're a big business like Kenwood or Icon or someone, and you've got huge volume, you've got huge global business of distributors and service agents, then it's a much easier thing to do. We have a guy in the US who helps sometimes with some US shipments, but the problem also is that as the range keeps evolving so rapidly, and sometimes part of the way I keep the prices so low is that sometimes I'm manufacturing as quick as I can, and if there are any issues, we have to fix them here before we ship it. And that would be very hard to do if we had a distributor network, how to keep everybody in stock of everything and to keep everybody with the latest version of everything. Because what happens when I do a PCB revision, however minor it is, everybody wants the latest PCB revision. And it would be very hard to somehow synchronize that between distributors in different countries. So it's something I've considered, but I think the overheads to doing that would be really enormous, and the administrative overheads to doing that. And right now, given that I can hardly keep up with my emails as it is, I would be quite scared to attempt such a thing.
I understand, yeah. And
I don't think it's very simple to do it. We do it with the guy in America, but even then it's quite complex, and that's just with one. So
just another thought as well, as I did mention it earlier, my kit that I showed earlier is one of 7 that my club, just 7 of us got together. I just did a simple advert in our newsletter and 7 people interested, and we did make a big saving. In fact, I can tell you exactly that we split the shipping between all 7 of us, and we paid £6 each for that, and it came within a week. Using DHL. So I can at least suggest that as an idea, that if you're a member of a club and you know other mates, and friends, who you could just talk to them and sort of consolidate shipping, you'll find that the shipping does not go up at all linearly with the number that you order of kits. So that is
that's right.
a real active suggestion for you, because you can make quite a saving.
I think up to 2 kilograms, for example, DHL shipment is the same. And for some countries, particularly, for example, the US, FedEx shipping goes up extremely slowly with the weight. So
I guess a lot of the cost is a lot of the cost is in that physically collecting the parcel from you and then getting onto the carrier and then delivering it again. So whether it's a very small package or whether it's very large, it's a similar cost. So I guess that's why. So it's worth thinking about, Mark. I hope that gives you something to sort of have a think about. Lots of comments, by the way. I'm filtering, by the way, Hans, some of the compliments, lots of compliments actually, all compliments and comments, because we haven't really got time to cover those tonight, but you'll be able to look at those yourself after this presentation, because of course this will, like all our Tonight at 8 webinars, will be on the RSGB YouTube channel for you to watch and watch again at any time. Now I've got a question now, a couple of 2-part question really, actually from somebody I think who's in Turkey, Gökhan TA9M. He has said that a software update was coming for SSB use. We are impatiently waiting for the update. He did, by the way, ask this question before you talked about it in your talk. In general, the QMX does a very good job in FT8 and FT4. I advise. And then his second part is more of his question. I've been using the QMX for about a year, a nice stable device. I just couldn't get technical support. It's very difficult to reach you by phone. Sometimes we have questions and cannot contact. So can you just address that for Guka?
Mostly I'm doing support by email. I do not remember if I've had email from Gökhan particularly. I can check that. But most of the support is by email. We have a help desk system, help desk support ticketing system on the website as well. And I do try and answer them as quickly as I can. There are times like the last 3 months when I was trying to finish QMX Plus in time for Dayton launch, and then the Dayton trip and the Friedrichshafen trip last weekend, where I do end up getting very behind with all my emails. And sometimes I fail to keep up. So it does happen. But I would certainly suggest that if people, the best way to get support, if you have any technical problems, will be to go to the groups.io forum, because how many people we have on there, over 8,000 members on the groups.io forum, many of whom are offering good advice and are very, very involved in providing technical advice to people and support. And so that would be really the best way to get support, I would suggest. The SSB question I think I addressed already in the presentation. It is the number one task on my list now. And you cannot imagine how many times I got asked that at my table at Friedrichshafen. When is SSB coming?
I'm sure.
And I was almost answering it in my sleep in the end.
Well, can I don't want to pressure, because I know, and we've talked about other projects in the past between you and I, you know, that maybe it were announced prematurely, but could you give us any idea? I ask this for many who've mentioned it as well. I mean, are we talking months? Are we talking possibly 2025? An idea?
Hopefully we're talking weeks. I mean, it's my number one priority. And as I said, I think that we have plenty of capability in the hardware, the linearity of the power modulator, the CPU processing capability that exists there. So hopefully I would be talking weeks or a small number of months, not longer than that. Because it is my number one priority and everybody's screaming for it. So it should have been done already by now. So very urgent.
Oh, thank you. I'm sorry, I didn't want to push you too much on that, but I'm sure that answers. I think it's a conspiracy by the CW fans, really, to not let you do it. But never mind. I better not say that.
Well, I mean, there were some glitches in the CW keyer. There were clicks on the transmit receive switchover and then there were things like having adjustable side tone volume. And all of these things were really high priority for the CW people, for the existing CW users. And so there were lots of really high priority things that I had to attend to.
Yeah, of course. And it's right to get those features right first, isn't it?
Yeah, I think I forgot to mention in the presentation that the QMX and the QMX Plus run exactly the same firmware. So everything that is developed for QMX Plus will be on QMX and vice versa. It's exactly the same firmware file, the same processor, same schematic. The only difference is that QMX Plus has double the number of filters, so it covers 160 to 6 meters. And of course, it has the built-in GPS option and the RTC option. So apart from that, the firmware is identical between them.
That's good, and that for you as a developer as well, that'll help, won't it? When you
yeah. That's right, yeah.
Okay, a next question from Tom Tierney. On the various QRP Labs forums, you are answering questions about non-delivery, postage costs, missing components and general bungling, messing up of the build by the buyer. And then he says, why the direct input? I'm not quite sure what that means. Maybe he means, that's what he's put, so why the direct input? Tom, if you want to come back on that and elaborate, what I guess you mean from that is why you've directly got involved with the input on those comments. But maybe if we've got that wrong, Tom, please put it onto YouTube chat now.
So, yes, because we are a small business and currently we do have 12 people working here. The 12 people working here are doing kitting of parts, they're doing shipping of components, and many of them are doing assembly. And these are all local Turkish speakers. And so pretty much at the moment, yeah, I would love to be able to find someone technical, an English speaker, who could help and who could take on some of that support load. But at the moment, it's pretty much me, and so it's a problem. It's a growing pain of a business. How do you manage to grow the business and find the right people to do things and offload some of the workload off yourself? I mean, going back 6 or 7 years, it was literally just me. At the time of QCX being produced, it was only me doing absolutely everything. We had 2 people who were doing the packing, but apart from that, it was just me. Now we have a large number of people, but still, it's a business growing pains thing. How to find the right people who can take some of that workload on. And at the moment, as the only person, it's all on my shoulders, as well as all the technical development as well.
Yeah, and it's important not to leave the development behind. So, I must say thank you as well, again, for being so candid about this, because some people would just hide away from these things. But you're being very honest and open, as you always have been when I've met you over the last few years, doing these sorts of webinars. So thank you for that. I'm sure everybody respect that. I mean, again, I so there's lots and lots of people complimenting you, and very pleased. I'll read just one out that I've just popped onto the screen. David Thomas says, I recently finished my kit and it worked first time, thanks to the excellent design and comprehensive documentation. And I'm sure that must be the case for most of your customers, or you simply wouldn't be able to cope, would you? So the forums are a good place, aren't they, to share problems, queries, that sort of thing?
Definitely, the forums are the place. The forum is the place to be. And when I'm overloaded, so overloaded that I can't keep up with my emails and messages, then the forum is definitely the place to get help. And so, I think many people have a successful building experience. Hopefully, the ones that don't can find help to sort out the problems. I think it's important to remember that you never have a guarantee of when you build a kit that it's going to operate perfectly, and this is a occupational hazard when you build kits. Now, I have a kit. I have it here. I'll show you. Norcal. This is a Norcal 40A kit, which I bought in 2007 at OZCon, and it doesn't work. So, at some point, it's on my shelf, and I'm going to have to go back and figure out how to make it work and what's wrong with it. But hopefully, most people are achieving a successful result, and I'm pretty sure that's the case. Otherwise, I probably wouldn't be here today talking about this stuff.
I don't think you'd have 12 employees as well now that you had, because when I first met you a few years ago, just beginning COVID, I think, online, you literally, as you say, you didn't have any, and you were just looking for someone then to help you with the technical side. So I was really shocked when we talked a couple of weeks ago for the rehearsal for this, and then you said to me, well, actually, I've got 12 people now, so that's great. Thank you. As I said, lots of people, lots of compliments, believe me. We're coming towards the end of our time now. I've got one more question to read. So if you have got a question, though, for Hans, or any other thing that you'd like me to read to him, please do it now on YouTube chat or BATC. This next question comes from Ian, G0UPL, who says, can the future include auto-logging for portable use? Another suggestion.
Yeah, that's a very good question, and something that I had also considered. And I didn't mention this in the slides because there are so many things I can think of that I would want to do with QMX Plus, and the space is there to be able to do it. The CPU power, the memory space. There is an EEPROM chip in the QMX Plus, which is 128 kilobytes capacity. And one of the dreams that I have is that I would be able to make an automatic logging tool. There are some other radios which do this sort of thing, like Elecross New KH1, just logs the incoming decoded CW and decoded what you've transmitted. It just logs that straight. What I would like to do is go much further than that and create an auto logging tool which can detect the call sign of the other person and your call sign and what report you're sending, and try to, as much as it can, obviously no CW decoder is completely perfect, but try to, as much as it can, construct a log from that, perhaps with a few things which need to be added by you, and then produce a standard ADIF style output file which can be loaded into other programs. And of course, we've got the USB connection, and we've got the capability for the QMX Plus to behave as a USB flash drive for copying files off of it. And we've got plenty of space in that 128 kilobytes of EEPROM to be able to store these kind of things. And so definitely that's one of the things that I would like to add, so that you've got a really powerful logging tool built in. It's obviously down the priority list from other things like SSB and the basic scripting and the variable CW filters, is obviously down the priority list from those. But definitely I think it's possible, and I already have been thinking about that and dreaming about how I will be able to implement that. As I said, the radio has so much, the hardware has so much capacity that you start thinking about all these things that you could add to it to make it into kind of perfect device.
Yeah, and we're looking forward. I think a scripting project will be brilliant as well, because that does allow people to tinker, as you say, and takes some of the pressure off you for some of the more, so shall we call them, esoteric, specialist little things that you couldn't really justify working on either. That sounds great. Got some more questions for you now. How does from Mike Smith, G0RFD, how does it handle 12 to 16 volt power?
At the moment, I recommend not using it above 12 volts supply. The switch mode power supplies will handle it, but if you go above 12 volt power supply, and if you're using digital modes which have high duty cycle, then you are likely to risk overheating the power amplifier transistors. I have routinely run mine on very long JS8 call overs at 14 volt supply, but that's into a well-tuned antenna and with a perfectly set up QMX Plus, and so I recommend not pushing it. The actual additional benefit you get from those few extra fractions of a dB is not really worth the risk to the radio. And so I would recommend, if you're using digital modes, don't go above 12 volt supply. With CW mode and in future with SSB mode, it'll be less critical because those are much lower duty cycle modes. But if you're doing digital, I would recommend not more than 12 volt supply. That's at the moment. There are also possibilities, other things I want to try to do in the firmware is implement a calibration routine which self-calibrates the transceiver and works out a multiplication factor for the gain of the amplifier such that it can set the power output to something like 4 watts, 5 watts, regardless of what the input voltage is. Now that extra voltage would be dissipated as heat in the power modulator transistor, but that would be much less stress than on the BS170s themselves. And so there are possibilities that exist for future that I might be able to make it cater for higher supply voltages relatively safely, even on high duty cycle modes. But this is going to require more investigation. And for now, I recommend not going above 12 volts. There's a variety of ways of achieving 12 volts. There are supplies which will produce 12 volts from a variety of inputs, or even the very simplest way, if you've got a supply which, for example, is 13.8 volts, then you just put a couple of diodes in series, a couple of 1 amp rectifier diodes in series. Each diode will drop the voltage by 0.6 volts, and so it's quite an easy way of dropping the voltage a bit. Yeah, I hope that answers.
A good tip, and to be honest, that was exactly what I was going to suggest as well then, because as you say, a couple of, two or three penny rectifier diodes, 1N4001, that sort of thing, which have got just 50 volts, and that is a very cheap way, isn't it, of reducing the voltage, and it's fairly constant as well, unlike saying a resistor or anything like that where it varies. It's a good way of dropping, as you say, 0.6 or so volts. So very cheap.
There's some dependence on the supply current, but quite little. The radio also has a battery icon which can be configured on the display, or you can actually read the voltage directly on the display. And there's also a protection feature, so you can set a maximum voltage, and if the supply voltage exceeds that, it will refuse to transmit. And so it has these built-in protection features and display features as well. But yeah, lots of possibilities.
Yes. And by the way, Ian, who asked the question a few moments ago, and then Mike, who asked this question as well, has said thank you very much for your reply. A very, very similar question, very well timed, from JP KA3BWP, who asks how fragile are the BS170s, which are the output power transistors, aren't they, that you mentioned?
Those are the output power transistors. Personally, I never blow them. So I don't find them that fragile, but there are people who say that they can be blown easily by antennas which have a bad SWR, or even by tuners, which auto tuners, which present a variety of bad SWRs momentarily until they find the best match. And so there are people who think the BS170s are a bit fragile. Personally, I haven't found that. I'm quite happy with mine. And as I said, I've used very long JS8 overs, which is a much higher duty cycle than FT8, and never had any problems with them. So it's kind of a contentious issue, how delicate are the BS170s. But I think if they're treated properly, then they're not too delicate.
Are they relatively inexpensive?
Oh, they cost a few. They cost a few cents. Yeah, they're very common, very inexpensive. It's also part of the thing that I've tried to do in all the QRP Labs kits is keep the used components relatively as far as possible to things which are common and easily obtainable and inexpensive. And the majority of the components used in these kits come under that category, and so easy if there are any problems. And BS170s are very, very good for this. They're a few cents each and easily obtainable. Another feature that exists in the QMX Plus is an SWR tuning tool, which will actually show the SWR on the display and generate RF at a reduced power level, which defaults to 25% of full power. And if you do that, then it would be very hard to blow the transistors through any kind of mismatch during auto tuning, for example. So yeah, I mean, my opinion, they're not very fragile, but not everyone would agree with me.
Well, and as RF output transistors goes, they're certainly cheap and easy to get hold of as well, which I know isn't the total answer. You don't want them blowing, but if you do, and then if you built the kit yourself, of course, as well, you'll know exactly how to replace them. So I guess that's a good out. Now I'm going to have to ask you a question now, which you won't like, but I've got to read them in full disclosure. But by the way, we're getting lots and lots of questions in, which is great. So I hope you're able to stay with us a little bit longer, Hans.
Yeah.
Dirk, PA3BYW, is QSX on hold now? I'm afraid
I knew you were going to say that.
We've talked about this before, haven't we? Yeah, we have.
That's right. QSX, so just for people who don't know, after I did the QCX project in 2017, which was for the Buildathon for the YOTA 2017, hosted by RSGB in UK, the next logical step seemed to be to propose an SSB transceiver for the following year's YOTA, which was being held, or YOTA Summer Camp, which was being held in Johannesburg in South Africa. And so that project was then called QSX, and I spent an awful lot of time on it. As soon as and I actually went to South Africa for the event and hosted the Buildathon myself down there. So I was there for a week in July, August 2018. And the Buildathon was great. Everybody enjoyed it. But they did not end up with a working radio because I had not finished the firmware for it. And as time developed on past that, and I was working on it frantically, because by then everybody knew about it and the news was out, two things happened. Firstly, more problems came up, which I had not foreseen, and which were hard to resolve. So these were RF problems, analog electronics problems, which is black magic. And second thing that happened was there was an awful lot of pressure. And more people were asking for more features and when is it going to be ready and so on and so forth. And frankly, what happened was for a while, I was just getting burnt out with the project. And I got miserable and depressed about ever finishing it and all the problems that were coming up and all the pressure I was having. And so in the end, I decided for my own sanity that I would work on a few other things in the interim. And in the end, I've worked on, as I said, the QCX Plus, QCX Mini, QDX, QMX, QMX Plus. All of those things have been worked on in the interim. The QSX does still sit here on the shelf, and it's not thrown away, and it's not retired. Try and get it in front of the camera there. So this was the original QSX prototype. It's not something that I consider that I've retired or given up on. It's something that I definitely do intend to get back to and to finish. However, having said that, in my opinion, I think that since 2018, there have been a number of other radios come onto the market at low prices, which achieve a lot of things, not as low prices as QMX Plus, but certainly low prices with good performance and features. And so probably to make a differentiation between QMX Plus and the future QSX, I will probably end up upgrading the specification of QSX. So perhaps to include, a color display with a waterfall and pan-adaptable display.
Careful, Hans.
And I mean,
no. But you did say as well, and you've always been open on this, and I'm going to come to your defence a little bit on here as well. I did some homework for Ready for Tonight, and I looked at your website today, and you've catalogued the whole story there, haven't you? The QSX, yes, from the beginning. Yes. And it's not dead, and you've still said at the end of that it's not dead. So please don't feel pressured, though, to talk about the features and things like that. I'm sure that it was just somebody, as you say, who saw it mentioned many years ago, and it's very brave of you, if I may say, to leave it up there on your website saying it will come, it will happen. But as you say, things move on. That's a long time, 6 years in technology.
It will happen, and it will change and be a higher specification than it was going to be, but the main thing that I learned from that episode is that in order to, when you create these radios, it's a very, I consider it a very artistic process rather than purely an engineering process. And the artistic process doesn't work under huge stress. And so what I have done on all subsequent projects was developing my own private silence, or with a very small group of people who I confided in. And I think all of these projects, whether it be QCX Plus or QDX or QMX, they all just came as a total surprise to everybody because I just worked on them quietly until I was ready and then announced them. And that's my way now, ever since what happened with QSX. That's the way I'm doing things now, so that the artistic process can happen in its own peace and quiet without any stress and
because
pressure.
I respect that, and many others will respect that. That's why it's not on my list of questions here, is what you're doing next, because I don't want to put you under that pressure. I think you're absolutely right. Let's move on, because we've got quite a lot of questions to get through. From Dave V3ZZY, any luck solving the band jump from 160 to 80 meters?
This is a very trivial thing, and it's something, a known issue, and as I said, the last couple of months have been very hectic with Dayton and Friedrichshafen. What he's referring to is that QMX Plus covers 160 meters, but the 160 meter band doesn't work properly. And if you power up in 160 meters, as soon as you touch the tuning knob, it jumps up to 3.2 megahertz. And this is a really, really simple thing for me to fix. And I know where the problem is, and it doesn't exist in QDX. And just very briefly to explain what happens, the SI53551A generates quadrature mode local oscillator, so it produces an output frequency which has two signals with 90-degree phase offset that are necessary for the quadrature sampling detector. This only works down to a minimum frequency of 3.2 megahertz, so it will only cover 80 meters and up. In order to make it work for 160 meters and below, which do work on QDX, so QDX works on 160 meters, 630 meters, and 2200 meter bands, you have to do a different technique to get the phase shift. And this was there was a Japanese radio amateur who published a page about this, and I do that on that same technique. What you do is you separate, you have a slightly different frequency, and you set the radios in phase on two slightly different frequencies, and then you wait for a defined number of milliseconds for the phase to drift apart by exactly 90 degrees, and then you put them back on the same frequency. And the only reason why 160 meter is not working on the QMX Plus is because I didn't yet link up a timer to calculate those number of milliseconds, and that's the only reason. So it's going to be really, really easy for me to fix that. I have no worries about that at all.
Yeah, thank you. It'll be on the list of things, and I understand all the time. You can't ever develop probably a product nowadays which hasn't got bugs and little things to fix. So, but thank you for answering that.
There's a trade-off. There's a trade-off, right? If you try to develop a hardware or even a software which is completely bug-free, it takes a lot longer and costs a lot more. And so there's a trade-off in being fast and being low-priced that involves some risk of there being some bugs, both in hardware and in firmware. And so, I try to make that balance all the time, that trade-off balance, to try to keep the prices low and keep things moving. But it does mean that sometimes, yes, there are problems like that.
Over my years, I ran an electronics design and building company for about 40 years, and over my times, I had downtimes, difficult times when we got a product, including one which was ready to go out of the on a carrier. We had to win on the carrier, and I had to call it back. That was how serious. So I appreciate and understand the sort of challenges. But on my wall, and maybe you'd like to put this on your wall, someone once gave me a little piece of paper that said, there comes a time in the life of every product when you have to shoot the engineers and start production. And that's kind of where it was for me when I've got employees and customers waiting for something. But anyway, I've got a question now. I'm going to read it exactly as it is. It doesn't make total sense to me, but I hope you'll be able to make sense of it. It's from Mark Static. I don't have a call sign. What makes magnetic field make two-way data input? Is it difference circuit? How much radiation is too much? And then underneath that she put, I made working 196. So I imagine that might mean 1996. But do you know what he means?
I'm afraid I don't know what he means.
Okay. Okay. Well,
no, I can't.
Mark,
unless he comes back with a bit more detail on that, I'm not sure what I would.
Mark, if you could make it a little bit clearer for us. I'm not sure. Maybe there's a language translation issue there or whatever. But if you could do that, then I'll happily read that to Hans in a moment. Again, many comments and compliments. Garnet Ryder, you've changed the hobby with your excellent designs and kits. I'm very happy with my QCX Mini and look forward to purchasing a future multiband radio from your company. And in fact, an observation from QRP Life. I don't have a name or anything for there, but the QMX was the radio used at my recent activation from the backyard of the RSGB National Radio Centre. So there we are. That's a wonderful thing to have done from Bletchley Park, where the National Radio Centre is as well. Steve Taylor, no call sign, any chance of the personalised settings being saved so that when the firmware is updated, these settings don't have to be entered again?
Yeah, that's another question that comes up. So right now, all the configuration parameters are stored in the lowest few kilobytes of the EEPROM. And sometimes when the firmware is updated, now it doesn't happen with every firmware release, but some of and particularly in the early firmware releases, if the mapping of where the configuration parameters are stored in the EEPROM has to be changed, then when you upgrade the firmware, it will actually reset all of those settings. So this is a problem which does need to be solved, and I am aware of, and I will find a good way of doing this. So perhaps the way to solve it is to have some kind of output file which has a name-value pair, which can then be loaded back into QMX Plus to repopulate whatever variables have been reset after a firmware update. There is a myth that a firmware update always requires a factory reset or losing all the variables. In fact, this is not the case. It's only some firmware updates where the EEPROM mapping of the memory parameters has changed, that this is necessary. So yes, it is something that I'm aware of, the need to do that, and it is also on my list.
Okay, thanks, Hans. We're coming to the end of the time really now, because it's getting near 10 o'clock in the UK, and I know much later for you. Again, lots of compliments. I'm trying to literally find the questions in amongst the compliments, which is wonderful. Someone asked when SSB is going to be implemented. I think you've answered that. It's hopefully weeks and certainly not more than months. Various people with various suggestions about reducing the voltage using the 7812 regulators, things like that. But as you've discussed, they obviously inefficient, that sort of regulator, because it dissipates the extra voltage in heat, doesn't it? What a question. I hope this means something to you. It doesn't to me. From Zafar TA2 VCO, will we see the green alien paddle in the QRP Labs shop as option for the QMX Plus?
He's talking about, and I've got my suitcase behind me still packed up from Friedrichshafen. I came back on Thursday morning. He's talking about the Palm Radio special edition green paddle. That now Palm Radio is not officially trading right now, and Hannah's DL9 SEO does have a few pieces of old stock which she's selling from time to time, and I do happen to have one. So, but this is not something that will. I don't think this is something that would be an option in the QRP Labs shop. Unfortunately, I mean, they're fantastic keys and have an extremely high reputation, but very hard to get hold of now that Palm Radio is not trading officially anymore.
Okay. One last little question from NSTA9AAR, so lots of locals for you, I guess. The QMX Plus device is a nice device. An idea came to my mind just now. In case of heating of the device, is there a small fan for cooling? I guess you've got the space in there if you needed it.
You've got the space, you could add it. I haven't included anything like that, but there is plenty of space that you could add such a thing if you felt that it was necessary. Do some drilling on the panel and include the fan inside. There's plenty of space. But I personally don't think it's necessary. The QMX has the same schematic as the QMX Plus, and the QMX is a very much smaller unit with a much lower capability to dissipate heat, and it still isn't a problem there either. So I would say, depends, maybe if you put some Raspberry Pi or something in the top half of the enclosure that generates some heat, then you might need to have a fan. But other than that, probably not necessary. But you've got the option, you've got the space if you want to do it.
Yeah, and maybe some holes for ventilation or flow of air, very important as well.
Yeah.
That's the end of the questions. I think we covered everybody. I hope we did for you. I'm going to leave the last words really to one of our viewers, who's John M0MJE, who says, "Thank you, Hans, for a brilliant and informative presentation. The open nature of your information is refreshing." And I echo that, and I'm sure many others who've watched tonight. Thank you very much indeed for joining us tonight, Hans. And as I said, really, genuinely, thanks for being so open. It makes us feel very much in touch with your designs, and we can't wait. Even though you're not going to tell me, I can't wait to see what you come up with next. And I'm looking forward to.
I'm not even sure myself. To be completely frank, David, I'm not really sure myself, because I know that what I did with QMX and QMX Plus was produce an extremely powerful hardware platform with a huge amount of scope to develop and evolve the firmware on. And so, right now, rather than look at some future product range in the near future, I'm thinking more about what firmware I've got to implement on the existing QMX and QMX Plus, because there's so much more to do in these radios, rather than the next thing.
Brilliant. Thanks.
By the way, we have to thank my son here as well, because he's somehow come out of bed.
I was going to say, he's up quite late, isn't he?
Come and say hello to everybody.
Hello.
Hello.
He's escaped out of his bed. He was 4 last week, but he's been very good. He's been sitting here very quietly, not disturbing me. So
when we met,
now he can say hello.
Oh, lovely. What's your name?
What's your name? What?
Lisa.
No, it's not. Your name is Atla.
Well, lovely to meet you. And I know you have your daughter. Last time we did meet a couple of weeks ago with the rehearsal, you said your daughter was then helping and built a whole QMX, I think, or a QCX. So
yeah, she built a couple of QDXs. She built, I think, a QCX Mini.
Wow. And
she's done one QMX as well. So she's 10. She'll be 11 in October. And of course, we're on summer holidays here. The summer holiday is pretty long down here because it's so hot. And as an alternative to vegetating, watching television, she's spent some time up here building a couple of kits. So it's good for her education too, I think.
And looking a bit further ahead, it's nice to think that your company will hopefully go on to be owned by some of your family, maybe. You never know.
Oh, it would be lovely. I mean, it's something that we would all dream of, but often it doesn't work out, I guess. But it would be a dream scenario, yes.
Hans, has been wonderful, and make sure when we next meet that I can't show you an empty, unpopulated board of mine. I'm looking forward to building mine with Tammy's help as well, winding some of the coils. I think I've got to get her to do that. And I look forward to seeing you again. All the best for your business.
Good luck with that. And good luck with that. And, it's funny, when you said you hadn't opened it for a week, because I sometimes get people who write to me and they say, oh, I've had this QCX revision 1 on the shelf since September 2017. Can you recommend what modifications I should do to upgrade it, or what firmware upgrade there is? And it's literally 7 years ago, almost. And so hopefully you won't leave it that long.
I
And
won't.
good luck.
I promise you, we will make it. So I was looked for a nod on my left, my vision mixer here as well, my director here. Thanks very much again to you and your family for spending the time with us tonight. I'm sure it's helped lots of people understand how the QMX works. And also about you and your business, because at the end of the day, I think we're investing as much in you, honestly, as your product. So thanks once again, and all the very best.
Thank you very much, David. It's been an absolute pleasure. Thank you.
Lovely to see you. Thank you.
Bye for now.
Bye. And there we are. We hope you've enjoyed that. It does conclude this webinar. Thanks once again to Hans Summers, G0UPL, and also thanks to the team who helped put this series together behind the scenes. We hope you've enjoyed this Tonight at 8 and that you will be able to join us next time. We're having a little summer break for August, but we'll be back in September for Brian Colburn, G4NNS, who's going to tell us more about an update on the Meteor Beacon project, which is currently developing a network of receivers to record and analyse individual Meteor events. If you'd like to see details of future webinars or watch recordings of previous programmes in this series, please visit us at rsgb.org/webinars, where you can also send us comments and feedback. The theme of British Science Week this year was time, and both time and the closely related concept of frequency are, of course, of vital importance to radio communications. As part of its British Science Week activities, the RSGB announced a new challenge. Using readily available components, materials or other resources, provide a method of either measuring the frequency of a radio frequency source or signal, or providing a time reference to a radio operator or radio system. There are 3 age categories you can enter, and the deadline for entries is the 1st of September 2024. Each category winner will win £150, and the results will be announced at the RSGB convention in October. For more details of the RSGB Time Challenge, please visit rsgb.org/BSW. If you subscribe to the RSGB's YouTube channel, you will be notified of all upcoming Tonight at 8 webinars, as well as other new videos and presentations from the Society on a wide range of amateur topics. But until then, thank you for joining us, and until next time, this is David G7URP signing off and clear. Bye-bye.